Hello everyone, this is video 10.2 looking at angles and phenomena in the world. I'm just going to tell you right now, this video is going to be awfully short, which works well because video 10.1 was awfully long. So together they average out to be, they'll probably be about 15 minutes on average. But let's get started. So really there's one main topic to this section, and that is how we can use angles to show real world phenomena, quote unquote. And really, the only real world phenomena that's covered in this section is light reflection. And so there's a figure here that I found online. Um, and so it shows here's the sun. It's the thing that looks like the sun, and then here's our surface down here, which we can think of like a mirror. Um, there's a lot of subtlety to this about how this actually takes place that we're kind of not going to get into. So we're using a very sort of idealized version of this. And that's why I'm saying that we're going to think of the ground or the surface as being a mirror effectively. But the light comes down and then hits at this point and then bounces up. Now we have this thing here called our normal line, and you can see the word normal there. So the line perpendicular or normal to the surface. And so this figure kind of explains with this normal line is that it's going to be perpendicular to the surface here. And so once we have this line perpendicular at the point where the light is hitting, um, we can see, and we'll go back to red here. So here's our normal line, here's our right angle. And so now this angle from the normal line to the original beam of light. So here's our light traveling in this direction. And so then it's coming off this direction. So this angle of incidence here is going to be equal to this angle of reflection over here. Now, you probably be able to figure out that this angle over here is also going to be equal to this angle over here, that these two are going to be equal, because if this whole thing is 90 degrees um, over here, so if let's say that this is 30 degrees, then this is going to be 60 degrees because this has to make a right angle. And so then if these are equal, this is 30 degrees, which means this is also going to be 60 degrees. So these two 60s are going to be equal. But the way this is normally explained is that we're talking about these two angles in here, not the two angles on the outside, even though they're also going to be congruent. That's it. That's the whole section. Being able to look at this light hitting, being able to draw in that normal line, and then being able to use this idea that these two angles um, to the normal line um, are going to be congruent to each other. Um, Man, that's the whole thing. So I feel like this wasn't an awful lot. So I just wanted to add in something kind of quick here, and that's the idea of funhouse mirrors. So if you've never actually seen one in real life, I'm going to imagine most people have seen them in a movie or in a TV show or something. And so I wanted to look at like what this section is saying about normal lines and how this relates to what we see in a funhouse mirror. And so I tried to find a picture that sort of explained the geometry of it a little bit more, and I couldn't find one. So I just found this little picture that shows this guy standing here in front of a funhouse mirror. So you can kind of see here, this is a curvy shape here, and that's what makes it so distorted. And so if you look at up here, the normal line here is going to come off at this angle. It's going to be pointed up because the mirror is starting to curve. And then here, the mirror is kind of going this way, so it's kind of flattish here. And then here it's kind of angling in, and so it's going this way. And so the point is that you can see if we were to draw these rays back, this angle here starts to show how much distortion there is. And so as this angle as the mirror starts to curve more, this angle starts to get bigger. Whereas if we look down here at the bottom, this normal line would be going like this, and this normal line would be going like this. So down here, there's almost no curve. And so because there's no curve, these lines are parallel, these normal lines are parallel, and so there's almost no distortion. And so as these lines start to get more and more toward a right angle, the further away they get from parallel, the more they're distorted. So the angle that's created implies how much distortion we're going to see in the mirror. So it's just a way to think about what's happening in these mirrors. In a normal mirror, all the normal lines are going to be parallel. They're all going to be pointing right back at you. But in a funhouse mirror, those normal lines all start to get distorted, and as they get distorted, so is our image. So here's our checkpoint problem. Um, and so I really I really like this problem. And I know it says problemphysics.com, and this is not a physics class, but we're just kind of considering the figure here. So we've got our light source here. So you think of like a little light bulb, and it's coming here and it's hitting point A, this surface, and then it's bouncing off of that to hit B over here, this surface. So now what we want to find is this angle here. So what is this angle? So if we know this is 25, what do we know about this? What do we know about this? And then eventually finding this. So one step at a time, just start with the 25, just start with what you know, and just keep moving one step at a time. This is a multi-step problem. It's going to take probably 2 or 3 steps to get it. So if you don't see the answer right away, that's pretty average. That's to be expected. If you have any questions about this problem or anything else that we've seen in class or in the videos or in the book or anything else, make sure you bring those questions to class and we'll get them answered. All right, thanks.